this example here, we've been given a parallelogram, and we're then asked to find some, basically express some terms in terms of the vector A and B. The vector A here is the vector OA. So we move from O to A. The line we traverse represents the vector A because we're moving, well, the line has a certain magnitude and then we're moving from O to A, so that's a certain direction. Because this is a parallelogram, side CB of the parallelogram is parallel to OA and also equal in length. So that means the vector CB has the same direction as the vector OA and also the same magnitude. So the vectors must be the same. So CB is also A. Similarly, AB and OC are the same vectors. So if AB, the vector AB is B, OC is also B. With that in mind, we can now proceed to solve the questions. So we'll start with part 1. In part 1, we need to find 2OC, which means 2 times OC. So let's start by finding OC. What is OC in terms of A and B, vector A and B? Well, OC is simply B, as you can see here. So 2OC is 2 times B. 2 is a scalar, B is a vector. So that's part 1. For part 2, we need to express the vector OB over 3, or OB divided by 3 in terms of A and B. So let's start by representing the vector OB in terms of A and B. What is OB? OB. Well, let's see. OB is the same thing as OA plus AB. OB is OA plus AB. The vector OA is this vector A, and the vector AB is lowercase b. So we know that OB in terms of A and B is A plus B. But we're interested in OB over 3, which is simply A plus B all divided by 3, which is the same thing as vector A divided by 3 plus the vector B divided by 3. For part 3, we're told that, it says, given that the midpoint of line AB is M, so line AB is this line, we're told that the midpoint is a point M. We're asked to determine the position vector of M. So it's been implied that, or assumed that, point O is the origin. So to determine the position vector of any point, all you have to find is, well, let's see. For point A, the position vector of point A is the vector OA. You start from this reference point, the origin, and you go to A and you work out the vector. The position vector of point B is the vector OB, which we've worked out here. So for M, the position vector of M is the vector OM. Now, given that M is the midpoint of AB, I know that AB is the vector B. The vector AM must be B over 2. Let's think of it this way. If the vector AB is B, the vector AM must be equal to AB divided by 2. It must be half of the vector AB. It's just, if you think about it, if this is a vector and this is half of the vector, if this vector is the vector, let's say k, this vector must be k over 2. So it's that simple. So that means AM is simply the vector b over 2. What I'm going to do now is put this squiggly line on top of b instead of underneath, so that it doesn't mix up with this, well, symbol that signifies division. So we now know what AM is, but we've been asked to find the position vector of M. So that's what we're going to do. Now we're going to find OM. So we're going to start from the origin and try to arrive at the point M. So starting from O to A and A to M. So OM is OA plus AM. The vector OA plus the vector AM. The vector OA is A. The vector AM is what we just worked out, B over 2. So I'm replacing OA with A, and I'm replacing AM with B over 2. So the position vector of M, point M, is simply this expression here, which if you want you can write as for part 4, we're told that point E lies on OB and is such that OE, the ratio of OE to EB is 1 to 4. Then we're asked to determine OE. For part 4, we're told that point E lies on the line OB and is such that the ratio of OE to EB is 1 to 4. So we know E lies on OB. You can see line OB, and it's such that OE is obviously smaller than EB based on this ratio. From this ratio, you can tell that EB is 4 times larger than OE in terms of the length of the lines. What we're interested in is the vector OE, the position vector of E. Okay, how do we get to E? Well, if you think about it, if you go from O to A to B, then to E, you be able to work out the position vector of E. But that's long and probably more difficult than the approach I'm going to show you. Now, we're told that the length of OE divided by the length of EB is in this ratio, so 1 over 4. Now, if you think about it, for every 1 unit, if you understand ratios, then the statement I'm going to make next will make sense. This is OE and this is EB. If OE is 1 unit and EB is 4 units, that means for every 1 unit of OE, you have 5 units of OB, the whole line, O to B, which means that the ratio of OE to OB is going to be 1 over 5. Okay, so vector, the same length will apply to the vectors because the length of the lines correspond to the magnitudes of the vectors. So the vector OE divided by the vector OB is going to be 1 over 5. So OE, which is what we're interested in, is going to be OB times 1 over 5. OB, we've already worked out as A plus B. So A plus B times 1 over 5. So that's the position vector of E. So OE, to be more clear, or clearer rather, is A plus B all over 5. Finally, we need to determine the vector AE. So let's see, AE. If you go from A to O, and O, so that's one vector, and then O to E, the resultant vector is the vector AE. In other words, the vector AE is vector AO plus the vector OE. Now, the vector OA is this lowercase a here. So AO, which is in the opposite direction, is going to be minus A. So vector AO is minus A. Or just as a general rule, OA, or rather AO, is going to be equal to minus OA, because the only difference between these two vectors is their direction. In this case, you're starting from A and going to O. In this case, you're starting from O and going to A. The vectors will be, as you can see, they are parallel. They are the same. They're parallel. They have the same length, but they just have the opposite directions. So AO we know. What about OE? OE is what we worked out in part 4. So it means that the vector AE is AO, which we know as minus A, plus OE, which we know as, well, I can break this down into A over 5 plus B over 5. So plus A over 5 plus B over 5. This is the same thing as A over 5 minus A plus B over 5. So I'm just going to simplify the terms involving the vector A using what you already know from fractions. A over 5 minus A is what? Well, this is A over 1. I multiply this by 5 and this by 5. I have the same denominator. So what I have, in fact, I shouldn't do that. What I have is simply A minus 5A over 5. So that's minus 4A over 5. And that's what I have here. A over 5 minus A is minus 4A over 5. Plus B over 5. And this can be bunched up to give minus 4A plus B over 5.